Escaping a container can give you access to a whole server, so it's a precious technique for a cyber attack. Hi, I'm Daniel, and in this video I'm gonna show you a couple of ways to break out of a container sandbox, and then a few ways to prevent this from happening. But first, a quick recap for those of you that are just getting started with containers. Containers are a group of processes isolated from the rest of the system. As processes running on the same machine, all containers share the same host kernel. A program running in a container cannot access files, processes, or other resources outside the container sandbox. To implement this isolation, a few tools are used, namely namespaces and cgroups. Namespaces allow to achieve isolation in terms of resources. cgroups allow to track and enforce resource usage. Escaping a container means overriding one or more of these security safeguards and accessing resources outside the container without the privileges necessary to do so. It potentially can get you control of the host machine and all the other containers running on it. So buckle up, we are going to see some examples where we can achieve this. Quick introduction before we start. In these three examples, you will see me already inside a container with a shell. There are a lot of ways you can get there, for example by exploiting remote code execution vulnerabilities like log4shell, but that's the subject of a whole other video. If you want to see it, just leave us a comment and we will make it. So, for the first container breakout demo, we are going to abuse Docker in Docker, actually Docker out of Docker for this demo. Docker in Docker, Docker out of Docker were, I'd say, pretty common a few years ago if you needed to build Docker containers inside a container, for example, running inside some automation pipelines in GitHub Actions or GitLab pipelines. We are inside a container. We can only see the processes of this container. This container is based on Alpine. If we look at the file systems inside, we can see there's a very particular one, this run docker sock, which means the Docker socket from the host file system has been mounted inside this container. What does it mean? If we have the docker command available, like we do, we can do a docker ps and we see all the containers running. The containers running on the host actually. So we see we are the only container at the moment, but we could run a new container, for example based on Ubuntu, and it will actually run on the host system. So this is a container sibling to our container where we actually are. So the next logical step, of course, is running a privileged container with full access to the host. So we mount as a volume the root of the host. We name our container escape, of course. We run a privileged container. We add all the capabilities. We use the PID namespace from the host, and we also use the namespace from the host. And what happens when we run this container? It will run on the host and it will give access to all, basically, the functionality of the host. So we see our container running, we can execute a shell inside our new container, and it will be like functionally like having a shell inside of the host. We could see all the processes running on the host, including our container processes, of course, that container the processes. We could see all the files inside the mount point on the host, and of course we can see that the host is Debian. It's a Debian distribution, so we can then move on to do some things like writing files inside the host. We have all the privileges, so nothing is stopping us from doing that. For example, we can create this new hello file, and if we look at that hello file from the host perspective, so we are now exiting to the Debian system. We have running these containers. We see there's the file, and also we see that this file was written by root. So basically we had all the privileges available on the system. So for the next container breakout, we are going to abuse the release agent mechanism of control groups version 1. So we are inside a container. We can see only the processes inside this container. It is a Docker image based on Ubuntu. We can only see the files inside the image. So to abuse this release agent mechanism, we need to mount the cgroup directory, and we create an empty directory, and then inside we mount the RDMA control group. We can see its files inside the mount, and especially that release agent file we will modify in a bit. We then create a subcontrol group. We simply make an empty directory called test, and inside this test subcontrol group we see there are some files, some actually virtual files inside. For example, this notify on release, which has a value of 0. So we then put a 1 inside, which means we enable the notify on release mechanism. So next we need to know where we will write our output. So we search for the upper directory of the overlay mount for the image, and that's that. So this is basically on the host system the path where our container storage is, at least the upper layer for our container storage. What we are going to do is we are going to abuse the release agent to execute a script with high privileges, and then write this the output for the script inside the container so we can see it. So we just put as a release agent my escape command, which is a script we are going to edit right now. It is a simple shell script. We can, for example, print all the processes running on the host, and as an output for this command we just choose an output file, which we will find it inside our container. But here the script will execute with high privileges, so we can do basically anything. For example, we can write a file with some greetings, and we can write it to the host system. So you see, you could do very bad things with this. We then set the script as executable, and then we have already set the script to execute as a release agent. Then we simply need to execute a process that exits immediately inside the our test subcontrol group. So we add it to the processes inside our subcontrol group. That command exits immediately, and this is the only one. It will trigger the release agent. We see that in our output file, we see all the processes inside the container. Well, not inside the container, running on the base host. And if we exit the container and we look at the processes, we see that is exactly our output. And if we go to look at the file we have written, we see there's the file and it has been written some seconds ago, and it has our content. So we definitely break out. For our last container escape demo, we are going to see an escape based on a Kubernetes pod. This is based on a Kubernetes Goat scenario. You will find a link in the video description for this. So we are inside a Kubernetes pod at the moment. We are inside, of course, a container running on Kubernetes. If we do a df, we can see all these file systems mounted, but we can see some subpaths from host systems that shouldn't really be there. We can also see the service account token mounted on this container. We could, for example, use that to authenticate later. But let's look at the host system. So we can see actually the whole host has been mounted on this pod. So like we did with the Docker Autodocker exploit, we could just change root to the host system. We could look at all the files inside of the host, and we can go looking at varlib kubelet. We see it has a complete kube config we could use to authenticate to the Kubernetes API server, for example. And we can abuse this. Maybe we can use we can download the kube control utility and just write it somewhere. For example, in our kube control file, we can download it from the internet if there is an internet connection available, and then we can execute this utility using the kube config we found from the varlib kubelet directory, and we are basically authenticating as a Kubernetes node to the API server, to the Kubernetes API server. So we will have all the privileges that the node has. So we could, for example, get all the resources. We can see pods, we can see services for other resources. We do not have all the privileges, but it's okay. We saw that we had a service account token mounted, and for example, we could then abuse that to authenticate as that service account, and maybe that service account has privileges to do more things. So we can move step by step laterally through the cluster. But here basically we already broke out from the container at the moment where that file system was mounted in the pod. Why did the first container escape, the Docker auto-docker container escape work? It worked because we were able to use this socket, Docker socket mounted inside the container, to use Docker like we were on the host system and launch a privileged container. So how do you prevent this from happening? Do not mount the Docker socket inside the container, of course. There is no reason anymore to do that. If you need to build the Docker images inside a container, you could use a tool like Canico or Builda that are able to build container images inside a container without accessing the Docker socket or without needing the Docker daemon. But also, you should not run privileged containers. There is basically no reason to do that outside of a very few edge cases. And you should drop all unnecessary capabilities when running the container, and do not disable SE Linux or use AppArmor or seccomp with unconfined profiles. So why did the release agent exploit work? It worked because we were able to mount the control groups hierarchy inside our container, and we were able to write inside that hierarchy to make a new subcontrol group. And that is because the container was running with these options, AppArmor, profile, unconfined, and we had the capability sysadmin. We could also exploit this on a privileged container, for example, which means we would have additional capabilities outside of this. But yeah, only the sysadmin capability is necessary for this to work. How to defend from this? First of all, do not run privileged container, or do not run containers with this capability and AppArmor unconfined. You could also use modern distribution. Basically, all the major ones are deploying right now with control groups version 2, but also just adhere to the principle of least privilege. You see, if we do not add the sysadmin capability, our mount would have been denied. We did not have the permission. Again, do not disable AppArmor, SE Linux, or other systems security controls, because also AppArmor, the default profile Docker uses, prevents mounting of the control group hierarchy in this way. So very quickly, how do you prevent this escape from happening? Do not run the container with the sysadmin capability. Do not disable AppArmor or run with unconfined profile. Also, do not disable SE Linux or seccomp. But also, it wouldn't have worked if we were using cgroups version 2. So, run up-to-date software and distribution, especially regarding your base system and the container runtime. Why did the Kubernetes breakout work? It's fairly simple. We were inside this pod, this system monitor pod, which is part of the scenarios from the kubegoat. And basically the reason we were able to do everything was because that pod had a lot of things that were wrong. First of all, we can see inside its manifest in the pod template part of the deployment. We can see the pod is using the host PID namespace, IPC namespace, the network namespace from the host, and it mounts the host file system inside the container. We can see the security context inside this pod is privileged and also allow privileged escalation. So basically we could do everything inside this pod, and we could actually access all the host file system. So there are of course mechanisms to prevent this. The first one being not enabling all this privilege inside the pod, but also using admission controllers, things like OPA, Open Policy Agent, which could check the manifest entering the Kubernetes cluster and prevent this from happening, and also all the other security mechanisms we discussed earlier. And those were only a couple of examples of container escapes. If you want to know more, visit our blog. You can find in-depth articles on these techniques and what to do to prevent them. And subscribe to our YouTube channel, there's a lot more to come. Thanks for watching.